Hello everyone. Welcome back to Learning with Suji. Have you ever wondered how kitchen waste and cow dung can be converted into a useful fuel? In today's video, we will learn about biogas production, how a biogas plant works, the steps involved in biogas formation, its advantages, and its uses in daily life. By the end of this video, you will have a clear understanding of this important renewable energy source. So, let's get started. Biogas is a renewable source of energy produced from organic waste materials. It is formed when microorganisms decompose organic matter in the absence of oxygen. Common raw materials include cow dung, food waste, agricultural residues, and sewage waste. Biogas mainly consists of methane, CH4, and carbon dioxide, CO2. It is used for cooking, heating, lighting, and electricity generation. Composition of biogas. Methane, CH4 50 to 70%. Carbon dioxide, CO2 30 to 45%. Small amounts of hydrogen sulfide, hydrogen, and water vapor. Methane is the main component responsible for the fuel value of biogas. Raw materials used for biogas production. Biogas can be produced from cow dung, poultry litter, pig manure, food waste, agricultural residues, vegetable and fruit waste, and sewage sludge. The components of a biogas plant are mixing tank, inlet pipe, digester, gas holder or dome, outlet chamber, and slurry pit. First we are going to see about mixing tank. The mixing tank is the first component of a biogas plant. Organic waste such as cow dung, food waste, or agricultural waste is added to the tank. The waste is mixed with water to form a slurry. The slurry is stirred to ensure uniform mixing and smooth flow. The prepared slurry is then sent to the digester through the inlet pipe. The inlet pipe connects the mixing tank to the digester. It carries the prepared slurry from the mixing tank into the digester. The pipe ensures a continuous and smooth flow of slurry. It helps maintain the oxygen-free environment inside the digester. Through the inlet pipe, fresh organic material is regularly supplied for biogas production. The digester is the main chamber of a biogas plant where biogas is produced. It is a sealed, airtight tank that prevents oxygen from entering. Inside the digester, microorganisms break down organic matter under anaerobic, oxygen-free conditions. During decomposition, microorganisms produce biogas rich in methane, which can be used as fuel. The digester also converts the waste into nutrient-rich slurry, which can be used as an organic fertilizer. The gas holder or dome is the part of the biogas plant where the produced biogas is collected and stored. It receives biogas from the digester as organic waste decomposes. The gas holder helps maintain constant gas pressure for smooth usage. The stored biogas can be supplied through pipes for cooking, heating, lighting, or electricity generation. It protects the biogas from escaping into the atmosphere, ensuring safe and efficient storage. The outlet chamber is the part of the biogas plant where the digested slurry flows out from the digester. It collects the spent slurry after biogas production is completed. The outlet chamber helps maintain the proper level of slurry inside the digester. The slurry leaving the outlet chamber is rich in nutrients and can be used as an organic fertilizer. It allows the continuous removal of digested waste, making room for fresh slurry to enter the plant. The slurry pit is a storage area where the digested slurry from the outlet chamber is collected. It receives the leftover material after biogas has been produced in the digester. The slurry stored in the pit is rich in essential plant nutrients such as nitrogen, phosphorus, and potassium. Farmers use this slurry as an organic manure to improve soil fertility and crop growth. The slurry pit helps in the safe storage and utilization of biogas plant waste, reducing environmental pollution. The process of biogas production has 7 steps. They are: Step 1, collection of organic waste. Step 2, preparation of slurry. Step 3, anaerobic digestion. Step 4, gas formation. Step 5, gas collection. Step 6, utilization. Step 7, slurry removal. Step 1, collection of organic waste. The first step in biogas production is the collection of organic waste materials. Common materials include cow dung, poultry manure, food waste, crop residues, and vegetable waste. The waste should be biodegradable so that microorganisms can decompose it easily. Non-biodegradable materials such as plastic, metal, and glass must be removed. The collected waste is gathered from households, farms, markets, or livestock sheds. Proper collection and sorting improve the efficiency of biogas production. The collected organic waste is then taken to the mixing tank for preparation of slurry. Step 2, preparation of slurry. The collected organic waste is transferred to the mixing tank. The waste is mixed with an appropriate amount of water to form a slurry. The slurry should have a smooth and uniform consistency for easy flow. Proper mixing helps microorganisms decompose the waste more efficiently in the digester. The prepared slurry is then sent through the inlet pipe into the digester for biogas production. Step 3, anaerobic digestion. The prepared slurry enters the digester, which is an airtight chamber. Inside the digester, oxygen is absent, creating anaerobic conditions. Anaerobic microorganisms break down the organic matter in the slurry. During decomposition, biogas, mainly methane and carbon dioxide, is produced. The process also forms nutrient-rich digested slurry, which can be used as an organic fertilizer. Step 4, gas formation. During anaerobic digestion, microorganisms break down organic matter and release gases. The main gas produced is methane, CH4, which is a valuable fuel. Other gases such as carbon dioxide, CO2, and small amounts of hydrogen sulfide are also formed. The produced biogas gradually accumulates in the gas holder or dome of the biogas plant. The amount of gas produced depends on the type of waste, temperature, and efficiency of the digestion process. Step 5, gas collection. The biogas produced during anaerobic digestion rises and accumulates in the gas holder or dome. The gas holder stores the biogas safely until it is needed for use. A gas outlet pipe carries the collected biogas from the gas holder to the point of use. The collected biogas can be used for cooking, heating, lighting, or electricity generation. Proper gas collection prevents gas leakage and ensures efficient utilization of the biogas produced. Step 6, utilization. The collected biogas is supplied through pipes to the point of use. Biogas is commonly used as a fuel for cooking in homes and farms. It can be used for heating water and providing heat energy. Biogas can generate electricity using biogas-powered generators. The use of biogas reduces dependence on firewood, coal, and other fossil fuels, making it an eco-friendly energy source. Step 7, slurry removal. After biogas production, the digested slurry flows out of the digester through the outlet chamber. The slurry is collected in the slurry pit for storage and further use. This digested slurry is rich in plant nutrients such as nitrogen, phosphorus, and potassium. Farmers use the slurry as an organic fertilizer to improve soil fertility and crop growth. Removing the slurry regularly creates space for fresh slurry to enter the digester, ensuring continuous biogas production. Conditions required for efficient biogas production. An oxygen-free environment is essential because biogas-producing microorganisms can only survive and work in the absence of oxygen. A temperature range of 30 degrees Celsius to 40 degrees Celsius is ideal for efficient microbial activity and maximum biogas production. The organic waste should contain adequate moisture and be mixed with water to form a proper slurry. The pH of the slurry should be maintained between 6.8 and 7.5 to support the growth of microorganisms. A regular supply of fresh biodegradable waste is necessary to ensure continuous and efficient biogas production. Biogas is a renewable source of energy because it is produced from organic waste materials. It helps in waste management by converting biodegradable waste into useful fuel. Biogas reduces environmental pollution by preventing the accumulation of organic waste. It decreases dependence on fossil fuels such as coal, petroleum, and natural gas. The digested slurry produced is a nutrient-rich organic fertilizer that improves soil fertility. Biogas is a clean-burning fuel that produces less smoke and harmful emissions. It is cost-effective and sustainable, especially for rural households and farms with a regular supply of organic waste. The initial installation cost of a biogas plant can be high, making it difficult for some people to set up. Biogas production requires a continuous supply of organic waste to maintain regular gas production. Gas production decreases in cold weather because microbial activity slows down at low temperatures. Regular maintenance is necessary to keep the biogas plant functioning efficiently. Biogas contains impurities such as hydrogen sulfide, which may require treatment before certain uses. Biogas provides a clean and renewable source of energy for cooking, heating, and electricity generation. It helps in the proper disposal of organic waste, reducing environmental pollution. Biogas reduces dependence on non-renewable fossil fuels, helping conserve natural resources. The slurry produced during biogas production serves as a valuable organic fertilizer for agriculture. Biogas contributes to sustainable development by promoting clean energy and eco-friendly waste management practices. That's all for today's video on biogas production. I hope this video helped you understand the process, components, advantages, and importance of biogas. If you found this video useful, please like, share, and subscribe to support the channel. Don't forget to press the bell icon to get notified whenever we upload new educational videos. Thank you for watching. Bye.